All right, let's go ahead and focus on section 9.11, and here we're talking about a function and the inverse of the same function. So that's the key word. We're talking about the same function. Okay, so it says let f be a function whose domain is all real numbers, and then if the inverse function is its inverse function and its domain is also all real numbers. Okay, what basically happens here is that if you take a function and of its inverse function, they basically cancel each other out. So if basically the inverse function undoes the action of the original function. So what happens here is that these two will go ahead and cancel out, and then what pops out is the original input, which is just x. And same thing over here, these two would just cancel out, and what comes out is the original input, which is just x. So again, they basically just go ahead and they undo or undoes each other, and then you get the original input. So they both go ahead and cancel each other out. Okay, so let's go ahead and look at some examples. Let's look at the restricted sign function first. Okay, then it says the inverse function of x is equal to the inverse function of sine of x, and then what we now know of arcsine of x. Okay, the domain and range of original function of sine of x, we know this is from negative pi over 2 to a positive pi over 2, and the range is from a negative 1 to 1. Okay, the inverse function is very similar. Right now we have this new notation of arcsine of x, and here my domain and ranges switch from my restricted sine of x, and we're looking at this guy. Okay, and again, the quadrants that we're looking at is quadrant 1 and quadrant 4. Okay, you want to start asking yourself, is x in the domain of sine or the inverse function of sine? So like for part A, you're going to say, okay, is 1/2 in the domain of the inverse sine? And you're going to say, yes, it is. So that means I can go and cancel them out. And what pops out is the 1/2. Okay, same exact thing for part B. You're going to ask yourself, okay, is 3.5 in the domain of the inverse function of sine? Right, this one is no, so this one actually does not work out, and we're going to have an undefined answer. Okay, if I'm looking at part E, we're looking at the arcsine of sine pi over 3. So you're asking yourself, is pi over 3 in the domain of sine? And you're going to say, yes, it is. So pops out is a pi over 3. Okay. And then we get to part H and I. So part H, it says the inverse function of sine, and we're talking about sine of pi. Okay, so in here, right, pi is not in the domain of our sine function, but we can go ahead and evaluate it first. So here I'm going to go ahead and evaluate sine of pi. Right, here's pi. Coordinates are -1, 0, so the sine of pi is 0. So I'm going to go ahead and rewrite this as sine to the negative first power of 0, and that is what I'm going to go ahead and evaluate. Right, and this one is just 0. Right, again, we're looking at only the quadrants 1 and 4. So here is 0, so then that one just pops out as 0. Okay, same thing with part I. It says arcsine of sine of 7 pi over 4. Same exact thing, 7 pi over 4 is not in the domain of sine, but I can go ahead and evaluate it. So this becomes arcsine of sine of a 7 pi over 4. Where is that? Pi over 4, 3 pi over 4, 5 pi over 4. 7 pi over 4 is over in quadrant 4. So that becomes a negative square root of 2 over 2. Right, and we're looking at only quadrants 1 and quadrant 4, so this one's going to be in quadrant 4, and this one is going to be a negative pi over 4. Okay, go and do the rest of the sine functions, and then you can pause the video and come back. All right, same exact thing for our cosine function. Now we're talking about the inverse cosine function. And then now we have the new notation of arc cosine of x. Okay. Now the domain and range of my original cosine function we found to be 0 to pi, and then my range is from -1 to 1. And then domain of my inverse function, right, my arc cosine, they just go and switch. Okay, and again, my quadrants this time are quadrant 1 and quadrant 2. Same exact thing, you're going to go and ask yourself, is x in the domain of cosine or the inverse function of cosine? So if I'm doing part A, is 1/2 in the domain of the inverse cosine? You're going to say, yep, it is. So what pops out is my original input of 1/2. Okay, then we get to part C. Is -0.8 in the domain of my inverse function of cosine? This is yes, so I can go ahead and write that answer right there. Okay, part G, it says cosine of arc cosine of a -3 is -3 in the domain of my arc cosine. Nope, it's a little bit less, right? So this one would be undefined. And then we get to H and I, which is the same thing as these examples of our sine function, is that it might not be in the domain, but we can go ahead and evaluate it. Okay, so is 3 pi over 2 in the domain of my cosine function? No, right? So I'm going to go ahead and evaluate this first. This then becomes cosine to the -1st power. Cosine of 3 pi over 2, what is that? That's over here. So that's 0, -1. So that's cosine, that's 0, right? And so the inverse of 0 just gives me pi over 2. Remember, we are dealing with quadrants 1 and 2 only. So that is going to be a value of pi over 2. Okay, same thing for part I. 11 pi over 4 is not in the domain of my cosine function, so I can go ahead and evaluate this. This becomes arc cosine, let's see, pi over 4, 3 pi over 4, pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4, 10 pi over 4. So here's 11 pi over 4 in quadrant 2. Okay, cosine of that is going to be negative radical 2 over 2. And then arc cosine of this value, if we're focusing on quadrant 2, right, that's going to be a 3 pi over 4. Okay, go and fill out the rest of these examples, and then you can go and pause it, and we'll move on to the last part of tangent. All right, last but not least, we have our tangent function. Again, now we're focusing on arc tangent of x. We're talking about the domain of my tangent function. Remember, this is when we have our soft bracket. So I have soft bracket negative pi over 2, comma pi over 2. And my range is from a negative infinity to infinity. Okay, same exact thing for my arc tangent of x and its domain and range. They just go ahead and switch. All right, we're only going to do A, E, and F. So the first part of A, it says tangent of the tangent inverse of 4. So you're asking yourself, is 4 in the domain of my inverse tangent function? Yep, it is. So what pops out is 4. Okay, same exact thing for part E, is -7 in the domain of my arc tangent? Yeah, it is. So what pops out is a -7. And then we have part F, is 2 pi over 3 in the domain of my tangent function? No, but we can go ahead and evaluate it. So 2 pi over 3 is over here. What are those coordinate planes? Or that coordinate? Is that 150? I don't know, but your reference angle is pi over 3, so we know that there's only 1 3 in this answer. So this becomes tangent inverse of a negative radical 3 because we're in quadrant 2. And again with tangent, I forgot to add this, we're in quadrant 1. In quadrant 4, when we're evaluating these kinds of answers, so then this one with a negative radical 3 is going to be a negative pi over 3. Okay, and we're done.